sensors that previously wasn't being checked, but continue to not be checked, but now should have been checked. And it actually has to be, they just left it on after the launch of the pre-launch sensor, because if they were ever going to launch and then they auto-check and then they reset, it took forever to reset, so they didn't turn on straight away, they would run for a while, and then turn them on, so I'm sure it was definitely safe. However, it continued to run as it took off, it was too big, it didn't fit in the memory put it in, it rolled over to the memory next to it, and the whole thing crashed. And look, the unit of itself wouldn't have the worst thing, because it would have restarted or something, because it was designed to give a crash report. So like the stereotypical sort of like, too much fast enough, right? But this is like, tell like the bug in the following crash context information, right? And so it sent a debug message up the same link to the main processor, which didn't know that could happen in one of its navigation data, thought the rocket had something off to one side, tried to correct, because it had one off to one side, and threw it off to one side. They tore it apart, the self-destruct signal kicked in, and because a 64-digit number was tried to put in a 16-digit space, right? This whole rocket exploded and ultimately goes to the spacecraft, which is amazing. However, ESA did decide to refund it, right? So once like that era can have phenomenal implications. And that is pretty much it from me. We can think of I started with theory of the stuff we looked, and in some cases, yes, we have to get the maths right. We get it wrong occasionally, but we have to get it right in all these critical situations. That means we need people who are good at maths and put the effort in, because with maths, we can do more than our brains were originally built to do, right? We can go beyond our which I think is incredible. But ironically, to get mathematicians and people who have to put the effort and work hard, and more importantly, have systems that accept that humans will make mistakes, and we can use our same mathematical logic to have robust systems where mistakes don't become disasters. To have all of that, we need people who are going to raise their minds to learn mathematics, right? So I guess the other part is about showing people all the incredible critical mathematics that underpins our modern society. I also want to encourage people to have it. Maths is difficult, but the people who enjoy maths are not the people who find it easy, it's the people who enjoy how difficult it is. It's hard work, you get it wrong, but gradually it will teach you great habits, and gradually you'll get better and better at mathematics. So I'm around physically here, signing books if you want to get one afterwards. This video will end up on the internet. If you're watching it on the internet, you can order it from that minor mistake in the URL, it only works if you've got the domain in the wrong spot. Because I think I'm hilarious. Actually, people were like, but it doesn't work if you put the, like, I'm not going to find it on the book. And again, people have to own the book. Like, we don't think you've understood marketing that. So I will also be around signing books and calculators at this point, though. I'm done. Thank you so much for your patience. Thank you so much for letting that go. Some facts which were accepted by everybody: eat more plants and vegetables, eat a bit less of it, eat less processed foods and less sugar. But at least half of it was extremely contentious and without any evidence base, such as eat less salt, have more starchy foods, eat regularly small amounts and often rather than in short periods, have food supplements that use artificial sweeteners rather than sugar, and above all, count calories. And all this is without any real evidence base. Some of it has actually been disproven by other randomized trials. So the whole idea really of the last 40 years of nutrition and telling people to count calories has been totally flawed. Even the most hardened obsessional nutritionists cannot possibly count their own calories, even if they read all the labels and you only shop from a place that's counted it. Even those have huge errors in them. So if we've been counting calories and our obesity rates have been going up threefold over the last 40 years, something's very wrong. So this was all telling me at the same time as I was working on another field from the twins that there might be something else going on, and that's something else that to explain all these discrepancies. And what this was for me the understanding it's a new organ in our bodies, a newly discovered organ that we call the microbiome, which is the community of microbes that live in our bodies, on our bodies. We're surrounded by it everywhere in this room, but in ourselves, 99% of them live in our lower intestines. And this community, which includes bacteria, fungi, viruses, and other organisms that are archaea and protists, all live together, just like they do in your yogurt. They're nice, happy groups. And the best way to think of them is as a new organ. And together, they have as many cells, there are many organisms as there are cells in our own body, and they have maybe 1,000 times more genes. And each of those genes is capable of being a chemical factory that can pump out all kinds of chemicals, proteins, hormones that our body lacks. And so we can't live without them, and we've rediscovered recently how important they are to all facets of our life, and particularly how it interacts with our diet. Now, no two people are the same. All of you would share 99.5% of your genes with each other, your DNA, and in fact, you can turn around to everybody in this room and
and say, isn't it great, we're all fifth cousins. Some of you might be third or fourth cousins, really close. And so we realised that actually, as a group of people, we're very similar. But if I asked you to compare your microbiomes, you wouldn't be anywhere near fifth cousins. You'd probably be like 10th or 12th cousins, because you'd only share about 25% of your microbes with each other, and all of you are going to have very individual microbes, unique microbes only to you. And so, for some reason, they like only you, they don't like your neighbour. But these privileged have decided to take hold in your bodies, not someone else's. Because generally, these things are good. And this individuality explains why there isn't really one diet fits all. It explains why, when you put identical twins on diets, as they've done here, you get different, as well as differences between the twins, you also see differences in the population of fourfold differences in how people will gain or lose weight on exactly the same food. And we've all seen that. We've all seen some people that seem to do very differently. They say, I eat lettuce, and another says, I eat mashed cake every day. And we've always said, well, that must be genetic, or metabolism, or something. But it turns out, genes don't explain much of it, and most of that can be explained by the differences in our microbes. Now, these microbes do all kinds of things. I'm not going to explain all this, but just to open the scope of what these guys can do. They can alter whether you're likely to get an allergy. I mean, an epidemic, if you haven't noticed, of food allergy at the moment in young people. Whereas I didn't know anyone when I went to school who had food allergy. Now everyone's got it. And these microbes are the keys to allergy, about how our immune system recognises threats and gets it wrong or right. Also, they can change chemicals in the brain, make you hungrier, or thirstier, or choose certain foods. Certainly in insects, they can do that, decide what you want to eat. They can also alter your mood. They produce metabolites like serotonin, which are responsible for anxiety and depression, and many drugs are based on that. And they can do all kinds of things about controlling how whether your gut is leaking or not, or all kinds of other systems of how you digest foods. So it's huge. And we're just at the tip of the iceberg, really, about discovering all the things that these guys do. Now, to summarise masses of science into one picture is tricky, but I've at a stage in life where I can do this without people telling me off. Because people say, well, what is this microbiome stuff? I've heard of it. Every study varies a bit. And is there really one microbe that is responsible for one disease? And the reality is, no, the studies do differ. They've been relatively small, but there are some consistencies. What we find in every single study where we compare people, a group of people with a disease, say it's diabetes, or it could be colitis, or food allergy, or Parkinson's, or depression, whatever it is, with another group that's super healthy, we'll always find that the group with the disease have a less diverse microbiome community. They have less species. If you count them up, there just aren't those number of plants, if you like. And so that's why I've used the analogy here of the garden, the English country garden, is what you would like to have. Okay, so you guys are all super healthy. You've got English country garden type microbes, lots of different species, all interacting with each other in a fertile soil that contains both fungi, it's got microbes, and everything's feeding off each other. That's the main key here. Now, we did something called a citizen science project for the last few years with our American cousins, and this was people who were interested in their gut microbes were donating, they're paying for their own research really, and you can still do this if you join the British Gut Project. You pay a small donation, and then you give a small donation of your it's poo, we call it poo in the post, and you send it back to us, and we sequence it genetically in the same way we would look at your genes, we look at the microbes, and that's how we discover what all these species are. So we put it all together, big computers, and start looking at these patterns. And this is of 11,000 people, and we can clearly show some patterns, we can clearly show differences between Americans and Brits, just based on their microbes, and we can tell differences between northerners and southerners, and people living in the country and people in towns. Now, we can't go to individual differences.